Okay, this is my SRT521-LAB6 demonstration. For task one is just a repeating of Lab 5, so I'm not sure if you want me to demo this part, but I'll just explain the code because it's pretty self-explanatory, or we've already explained it. Reads the dataset, lab6 dataset.csv. Takes 30 samples from malware and Bay9 class, creates a variable called testsamps, where it's going to combine the malware and Bay9 together, and we're essentially just saving that to CSV, and then whatever's left, we just save it to what's left.csv. I've attached the CSV to my submission. For task 2, so this is where we're actually doing stuff here. So here we are essentially playing around with the hyperparameters. So again, we're just importing modules, reading the data set, and yeah, this is just all a repeat really. So here is where I'm essentially setting the spectrum of inputs for max features and max depth. So these are the two hyperparameters that I'm going to be playing around with. So for max features, I'm going to have it test square root of the total amount of features, 10, 15. And for max depth, the spectrum is going to be 5, 10, and none. So we're essentially using these inputs down here. So essentially we're creating a for statement in which it's going to loop back to all those inputs and it's going to test all these out. So we're basically saying, so this is the model. So from lab 5, we chose the random forest classifier. So that's what we're going to be using here as well. So we're going to be saying for max features, hyperparameter, we're going to have those inputs that we set from earlier, and for max depth hyperparameter, we're going to have those inputs from earlier as well. And then this is just a repeat, but we set scores and cross validation score to our XY model, and we're scoring F1, and we set the number of folds to 10. And then it's simply just going to print out the, so A, it's going to print out the the max feature input, so whatever it uses from here, and then whatever it uses from the max depth as well. And then it's just going to print the mean of the F1 and the standard deviation of the F1. So I'll run the code just so that you can see it works. I believe that should take a while. Oh, actually it's pretty quick. So yeah, it's running through the combinations that we set, as you can see. And it's going to print out a total of 9 because 3 options times another 3 options is 9, so there's only 9 possible combinations it can go through. So it went through all 9, and then you can see the score and the hyperparameter it was set to, or the combinations here. For task 3, so this is my random search. So this is a pretty short code, but essentially does all the same. Importing modules, and it's going to read the CSV that we created from task 1. We set it to XY, basically dropping the other columns that we don't want, and grabbing the column we do want, which is target. So for here, we're basically doing this kind of the same thing as our last code, where we set the hyperparameters that it's going to, how do I put this? or it's gonna use random search on. So it's going to run through the combinations of these hyperparameters that I've set. So max features, max depth, bootstrap, and then these are the inputs I'm gonna have it run through, and then like different combinations it's gonna run through. And in this case, it's random search, so we can specify how many combinations it tries, and it's going to essentially run through literally what it says, but random sample combinations as it's doing this, and it's not going to try every combination, but it's just going to try 60 as we specified here for the sake of time. But yeah, this is basically the module from that we're importing from randomized search CV, and so it's going to use our parameter set here. It's going to try 60 different combinations. It's going to use the F1 scoring, and it's going to use 10 splits. So this one takes a while. So I'll have this one running in the background. Oh, one here. Task 3, random search.py. So yeah, this one takes a while, so I'll leave it at that. I'll move on to the next one. Code, same exact thing, except I I changed the amount of inputs it's gonna take, just because this is the one that actually tries every combination, so it's gonna take a really long time for the code to run if I set more. But essentially we set the hyperparameter and the inputs it's going to try for the combinations. The same exact thing, but instead we're using grid search. So we're using the grid search module, and it's going to use the hyperparameters we set, again scoring F1, and it's going to use 10 split. So let me just run the code. Not picking it up. Lab6, task 3. I should have it in here. Oh, my mistake. So CD Lab6. .py. So this one takes a while too, but yeah, so those are going to keep running. So I'll let those run. And then for task 4, I couldn't finish all of task 4 just because I couldn't get it to work. But I did get it to essentially create the model using the parameters that I found to be the best scoring from task 3, which ended up to be the max features being set to square root of total amount of features, max depth set to none, and bootstrap set to true. And then essentially just made the model persist, and I dumped it into Pickle. So that ended up with this Pickle file right here, as you can see. But this is taking just a tiny bit of time, so just please give this a moment. I'll most likely just fast forward this portion so that for time's sake. Or at least when it comes to the grid search, tested out every combination, and it printed out. So the best parameter is bootstrap set to true, max depth none, max features square root, and the F1 score is 0.86. So basically 87%. So that's really good. So that's the best there. And it's going to take a little bit more time for this one to run. And as you can see, it returned the best parameters. And yeah, that's my lab demonstration. Thanks.